Hello, everyone, and welcome to the Water Finance and Management webinar series. I'm Mike Kesdy, a contributing editor to Water Finance and Management, and it is my pleasure to introduce our presentation, Top Utility Challenges That Can Be Addressed by Your AMI Data. Today's webinar is brought to you by Census. We're going to take a quick poll, so please submit your answer and then click the blue Return to Presentation button. Any views or opinions presented in this webinar are solely those of the presenters and do not necessarily represent those of Benjamin Media, nor does Benjamin Media endorse any products or methods presented. Presenting today are Tom Galuska, Senior Product Manager for Water AMI at Census. He's responsible for new product initiatives and legacy product support for water communication products. Tom holds a business administration degree and an MBA from Robert Morris University. Also presenting today is Zachary Barkjohn, a smart water engineer in the Water Product Engagement Group at Census. Zach holds civil engineering degrees from both NC State University and the University of Illinois, and is a licensed professional engineer in the state of North Carolina. Following the two presentations will be a question and answer session. We encourage you to participate by typing your question into the designated panel in the left-hand portion of your screen. You can also maximize your viewing window by clicking the box with the X at the upper right of the slide. Now, please welcome Tom.
Good afternoon, everybody. Good morning, and welcome to the presentation. Top utility challenges that can be addressed by your AMI data. It's an automated world here, and we're well into second and third generation AMI solutions. So with that, I'm going to get started here. Before we get into the meat of the material today, which is how we're using AMR, I want to talk a little bit, a few bullet points on the current state of the water and things that we're going to try to address today. One is hopefully bringing some valuable insights into the water industry today and how we're all overcoming challenges and using technology and trying to get by on a day-by-day basis. Focus on some important issues. We know we've got a bunch of different issues within the industry today, and we'll try to focus on what you as utilities have communicated are important to you and how we think we can address those. Raise a little bit of awareness and assign priority to some of these issues. Some of the recent activities over the last year has kind of accelerated priorities with utilities of being able to be prepared for disasters and resiliency. And so we'll talk a little bit about that. And then discuss and identify some significant industry trends, some technology bases, and how the industry is either applying these or looking to apply them, or some of the things that are coming in the future. But before we talk about how we're using the data, let's go over some of the top issues that have been identified by the utilities through some surveys and through some other industry magazines and content. So let's talk about the first one, and this is a very important one that has been discussed for a long time, and that's aging infrastructure. Renewal and replacement of water and wastewater infrastructure is a top issue. This kind of goes hand in hand with the infrastructure itself and how old it is and the problems it can cause, with non-revenue water and water loss and other things that go along with that. So it's a national challenge. Many systems, particularly in larger cities, have water pipes in the ground that could be 100 years old, and they just haven't gotten to them, or they're causing problems. Municipalities are having to upgrade very old systems, including underground water distribution, levees. We all know what happened in New Orleans when the levees broke, reservoirs, and flood channels. All these are part of the infrastructure within North America that there's been a lot of attention to, and it's going to cost a lot of money to replace this. And sometimes it's a bit overwhelming to think about the dollar tag that's associated with this. So the ability for water utilities to manage this infrastructure, it's also dependent on how they have to communicate with their customers, because in many cases there's interruption of service. And so it's a fine line. People don't like to be inconvenienced, but at the same time, they don't want old infrastructure that could possibly cause poor quality of water and rates to go up and all those different things. So there's a fine line there. And some EPA data estimates that $473 billion in drinking water infrastructure investment is going to be needed over the next 20 years as pipes and storage facilities require upgrades and replacements. So that's a lot. That's a big price tag, $473 billion with a B, as our things. And that's probably on the low end, probably a little bit higher than that. You know, in association with aging infrastructure, that leads to leaking pipes. We all know what kind of problems that is. If you look at the picture that I have on the slide, that's an actual utility and them trying to find the shutoff valve and stop that problem and repair that. That's a thing that happens on a daily basis. So water loss from leaking pipes is one of our biggest challenges that we face as a water utility. It's estimated by American Society of Civil Engineers 6 billion gallons of treated water are lost every day in the United States due to leaking pipes. And an estimated almost 250,000 water main breaks occur every year. That's a significant number. Not only does this result in water loss, but it's also a loss in revenue for the utilities. There are some utilities out there that they have a water loss representation of maybe 20%. Some are higher than 20%. So when you start having water loss, you also have the risk of contamination. And we as a society are very conservative conscious, and we're asking our customers to save water, but we have vast amounts of water loss that we see ourselves through leaking pipes. So we have water that is unaccounted for, non-revenue water that, you know, it's a continuous problem. It's a thing that's cyclical. We've got to try to move through our system to repair these things as they get older and try to figure out where our leaks are so that we can save. Another issue, a top issue, is water contamination. So water contaminations or issues are sometimes a result of aging pipes, or pipes that contain lead or copper. Flint, Michigan comes to mind. That's probably the most advertised, not the correct word, but the one that's been in the news over the past couple of years and caused the biggest problem, and that's due to lead in the water lines. That again goes back to aging infrastructure and the ability to replace it. Contamination also can occur because of bacteria or floodwaters, causing the sewer overflow or saltwater intrusion. Other sources of water contamination, industrial activities such as mining and foundries, runoff from soil, air pollution and automobile emissions. We've got some situations where malfunctioning wastewater treatment systems, such as septics, can cause these kind of problems. Many areas we have leaking underground storage systems and pipes that we're not even aware of. Those are other sources of water contamination. And landfill leakage and sewer overflows. Those are all contributing factors to water contamination, which is dangerous for everybody and something that the public does not want to endure. They don't have to. Here is another top issue that's been identified by utilities, and that has to do with the fact that it is an aging population with regards to those that are working there. And so retirements, talent attraction, and retention, those are things that the industry is facing itself. The Bureau of Labor Statistics estimates that 8.2% water operators will need to be replaced annually in a 10-year period, and that number is from 2016 to 2026. That number has probably increased, so that's probably a conservative number. A lot of smaller water utilities in rural areas might be hit the hardest. They've got a decreasing workforce. They don't have the pool of potential workers in those smaller rural areas. The larger urban areas might have a larger pool and might be more desirable for people to work in those areas due to many things. And so the water industry is going to continue to require professionals to be properly trained in the latest technologies. As we progress as a utility or as an industry, more and more things, it's requiring more education, more certification, and in a lot of areas they're requiring degree to work in the utility or the wastewater. And so it's the qualifications, the bar has been raised somewhere a little bit higher. So almost 1/3 of the water industry professionals will be at or nearing retirement in the next few years. And that's a significant number of people that will be in the retirement area. Pre-COVID, unemployment rates were at record or near record lows, and other industries will be facing the same challenges and going after the same people. So it's going to become very competitive as the workers start going back after COVID, and so there's going to be a lot of people competing for the same resources to try to fill up their talent pool. So we're going to have to be creative in the industry to try to attract people and attract the right people so that we bring the right people in to do the job. Another one of the items that was brought up was implementing innovative technology. We all talk about it. We've all been talking about it for years. A lot of people have been active with it, and some people are still weighing what they need to do. But innovative technology can improve performance of water systems and relations between the water utility and the customer. The more access we have to the data, the more we can communicate with our customer, the more real-time information we can get to our customer, and we're all about trying to improve customer relations. So economics was cited as some of the biggest barriers to innovation in utilities. Depends on how you're looking at your return on investment. I can't think of a better investment for a water utility is to improve their technology, but you've got to look at it from more than just a meter reading application. It's got to be across all your systems and your processes to bring it all in so that you have a quicker and better return on investment. But innovative technologies is the way the market's moving, and most people are very familiar with that. So there are some regulatory constraints and some risk concerns. People are wondering, okay, if I invest now, is that going to change in 5 years? That's why it's important whenever you're looking at solutions and systems that you do things that are backward compatible and upgradable in the future, so you don't invest in older technology. So, but here's some of the top reasons why you should deploy a smart water system. State-of-the-art technologies adapt to existing infrastructure, so you're able to invest in a solution that allows you, as I mentioned before, to look at things all across your processes in your whole enterprise. Accelerating your field deployments, smarter applications allows you to do that quicker. Improve your system, process reliability, efficiency, and operability. So efficiency is the key name of the game, return on investment, flexibility across your enterprise. Those are all things you want to look at. and then really looking at reducing your operating costs or your bottom line. Everybody wants to reduce that operating cost, become more efficient, and move forward with technology. So those are some of the top industry problems that we were able to gear from surveys within the industry of what utilities think are important and are problems. We'll talk a little bit in a few slides ahead. Zach will talk about how we're using that to solve some of these problems. But I wanted to talk a little bit, a couple more things about resiliency, infrastructure resiliency, and emergency preparedness. I don't think any of us could have imagined a year ago that we would still be in this situation with COVID. But anytime there's an emergency or a pandemic like that, it leads to innovation. So crisis often provides motivation and focus to take action that would otherwise be deferred and minimized. And I'm sure that many utilities, once COVID hit and it was a wow moment, what are we going to do now? Either wish that they would have implemented some other technology or are really taking a harder look at it now. And also the technology they had, they are using things that they may have not used in a way they have not used before because of minimal access and access to workers themselves. A lot of workers are working remote. But a few of the examples, a water utility, some of the crises, and it goes way back to 1832, which was a cholera outbreak. That was the largest infrastructure project of the time. The Chicago fire design guidelines for water main sizing. They couldn't have predicted those kind of things, but that disaster helped design some of the guidelines for water main sizing, velocity, and hydrant placing. So that's a positive thing that came out of it. And then the 1969 Lake Erie fire, one of the many fires and pollutant incidents, led to the Clean Water Act of 1972. So positive outcomes from a disaster. And then, of course, we're all still in the throes of COVID-19. We're hopefully on the downside of that with the vaccines available and the numbers going down. But resiliency and emergency management challenges for utilities. Lots of utilities are looking at what could I have done different and how am I going to do things different in the future. So what's the future of water? Slides not advancing. All right, so buckle up. We've got intensity and number of challenges to increase, and I think we've always been under this strain in the water utility in the industry, but COVID kind of moved things forward, and some of the challenges that I had mentioned previously is retention of people, aging infrastructure, leaks, water quality, and pandemics. Those are challenges that we need to come that we can overcome. Necessity is the mother of invention. Every day, as a vendor, we look at our customers to tell us how we can improve on using our products to help them. So utilities themselves are looking to find ways to use technology to improve their operations. Future needs of foundation to support the structure, embrace the utility intelligence. Innovation, as we talked about earlier, helps us to overcome operational efficiencies and be able to better serve our customer base. Those are just some of the few items that we'll talk about as far as a water utility goes. And then as far as data, talk about going from monthly meter reads. If you are a utility that were invested just in getting a meter read from a customer, and let's just say you were 5,000 services, You gather the monthly read. You got about 60,000 meter read data points a year. Now, when you move to AMI and you start that same 5,000 service utility, and you're getting hourly reads, you're getting over 43 million data points. And that's just meter reads. That's not pressure, that's not temperature, that's not level, that's not any of those other things. So you're getting a lot of data. If you're just using it for meter reads, then your return is pretty scarce. And so, Zach, I'm going to turn this over to Zach, and he's going to talk a little bit about how utilities are using this data to move forward. And I will turn that over to you, Zach.
Thanks, Tom. So, as Tom mentioned, there's a lot of challenges that the industry is facing, but I think the message that I'm going to be speaking to the rest of this presentation is really that, technology has created new problems for us, new problems to solve. As Tom was saying, that AMI systems now just drastically increase the amount of data that we're getting. And so we need new tools, new solutions to actually help sort through that data and make information from it. And so while I'm going through these, we're mainly going to focus on technology, but one thing I want to recommend you keep in the back of your head is the human element. Tom mentioned the talent attraction and retention of employees and the challenges associated with that. And to think about how the next generation of employees are going to interact with your systems, knowing that a lot of them, especially the ones coming to the workforce now, they were essentially born with a smartphone in their hand. So as Tom mentioned, AMI creates a lot of data, and I'm guessing that most AMI or most operators that have an AMI system probably don't really recognize their meters or radios based on that unique ID. I know a few, but they're very few out there. Instead, we need that contextual data. So that's where the customer billing and CIS data comes in. And so we need to bring this all into a place where we can look at this together and aggregate it together. We need to leverage it in a single place. And so that's where analytics come in. So it's not just about the data itself, it's about contextualizing that data and making information. And so one of those ways we can do that is with device groups. So device groups, they can either be static or dynamic. So like a static group might be where you are static or defining groups based on the exact meter, but they might be dynamic based off of the location, say all of the meters within a zone, or the size meters. So you might create a group where all of the large meters are grouped together, customer type, etc. And so that can be really valuable for customer service because, like I mentioned, you could group these by size. As we know, most of our revenue for a lot of utilities comes from the largest customers. And so being able to keep your eye on those large customers can help us focus our attention on the important aspects, especially when it comes to revenue. And then we can sum this data as well into what we call a virtual meter, and this is nothing more than an aggregation of all those meter intervals into a larger data set. And this is useful for things like hydraulic modeling or demand forecasting. And then reports. This is another way. So where the device groups kind of help us focus on a particular type of customer or particular type of meter. Reports kind of take the opposite approach. They are more focused on certain types of behavior. And so, for example, customer side leak is one type of report that you define some level of consumption for some number of hours in a row. And if it violates that, say a meter registers over a gallon of consumption for 24 hours in a row, it could trigger a customer side leak alarm. And so this is a really useful tool for utilities because of, one, customer service. they can let these customers know that they've got a problem, and so then the customer finds out about it sooner, so maybe they don't have to deal with a bunch of their own property damage, flooded basement, stuff like that. It helps with conservation, so all of that water that would just been lost. And then bad debt. This is something that is often overlooked, is that a lot of utilities will actually write off bad debt for customers that say sprung a leak in their service line and didn't find out about it for a month until they get their next bill. They can't pay that bill. The utility knows they can't pay that bill, so it ends up just being written off as bad debt. With this customer side leak alarm and being focused on the customers that are having these leaks and alerting them sooner, they can actually change their policy saying, hey, look, you've got a leak. We let you know within 2 days. If you don't fix it within a few more days or a week or whatever the policy states, we can't forgive that debt. That's on you. And so that ends up saving the utility money as well. No reads is another useful type of report and can help identify which meters need to be picked up by, say, a drive-by route. Sometimes AMI systems will be designed knowing that there's going to be portions of the network that aren't covered as well, and so this can be helpful there. Others can focus field work. So a report that kind of draws employees to know which meters need to be meters and radios need to be attended to, say, if they're not transmitting data, maybe an animal chewed through the wire, something like that. The other thing that reports are really helpful for is with the workflow. Think about those small daily tasks that you do over and over again that are fairly repetitive. Anytime we have a task like that, chances are we can automate it a little bit better. And so this is helpful to kind of take the human element out of it and get you focusing on more important things or more interesting things. So one example of that is alarms. So with smart meters and AMI, we get more smart meter alarms. And so one of the things that our utilities have found is, all of a sudden we are getting no alarms because it didn't have any smart meters, to now having a bunch of alarms. We don't know which ones to prioritize. And so what this graph shows is the consumption of one particular customer meter over time, where you see the normal consumption there on the left, going right along, and then the utility received a tampering alarm. And this particular utility was seeing a bunch of tampering alarms, so they weren't sure which ones are real and which ones weren't. And so they ended up just pulling the consumption data and were able to look and see, okay, in this case, that tampering alarm was triggered, and then what we're seeing is the customer was actually going out and taking their meter out and replacing it every few days, so it looked like they had consumption. But by really diving into the data, they were able to see and prioritize, which customers to go out there and talk with. So we've been talking about how to take all this meter data and really turn it into information. But now I'm going to transition to kind of the other side of the same coin of what other data or what other information could we be getting out of our AMI system. And in a few slides, I'll talk more about why we want to consider our AMI system for these types of data. But first, let's talk about asset management. So asset management has gotten a lot more consideration in the last couple of decades. It's a very useful tool for making sure that capital expenses remain fairly steady and not all over the place. And so the great thing about distributed data, so getting more information from our AMI system, say it's pressure, flow, water quality data, all these types of data can be incorporated into asset management plans. Especially when you consider, say, like pressure, and you're taking areas where you've got high pressure, old pipes, that can feed into your asset management plan. But on the same time, these asset management plans can actually feed back into where you're monitoring. You may not have the capital budget, nor is it probably wise to just go replace everything that you think or that looks like it should be replaced. Rather, we can use monitoring to monitor those most critical areas to help mitigate some of that risk. One good example of this is one utility has a lot of elevation change in their system, and so they have a lot of PRVs. And one of their ways that they were mitigating risk was monthly they were going around and visiting each PRV to ensure that it was working properly. Now, once with the AMI system, they realized they could monitor the pressure at either side of the PRV to ensure that the PRV was working within every few hours. And so this greatly increased their serviceability because now, rather than having to wait potentially a month from when the PRV failed, they could know within a few hours. But then also they didn't have to send the trucks around, so it saved costs as well. And so kind of going on that same theme of pressure monitoring, and I see pressure monitoring as really the gateway to more distribution monitoring. And so this is an example of one utility that leveraged their AMI system along with a smart meter with an integrated pressure sensor, you're seeing down at the bottom left there, along with a radio over the AMI system hooked up to just your standard bullet pressure transducer shown on the top left and right. In the top left, that's in a commercial meter test port, and then on the right, that's actually at a PRV. And so what they did, utilizing those few tools, they distributed pressure monitoring across their entire system. And what they found was that they were able to recognize new problems much more quickly. And then when they found a problem, they were able to diagnose much more quickly. And a lot of that has to do with, in their prior workflow, if they got a customer complaint or suspected a problem, they'd have to go put pressure loggers out there, wait for a few days, then collect them, then analyze the data. Now that data is distributed around the entire system all the time. So what that kind of looks like, particularly, or this is one example of that utility, utilizing those pressure data. So this is in one pressure zone, and slide in advance, there we go. In one pressure zone where you can see they had fairly high pressures that were wildly swinging, and then there was a PRV failure. They used that failure to go out and implement some better pressure management. So they changed some set points on some PRVs, and they were able to not only smooth out those pressure fluctuations, but actually reduce the overall pressure in that zone, really extending the life of those pipes. Another big problem that Tom talked about was leaky pipes. And so one of the solutions to leaky pipes is district metered areas. Technically, district metered areas have been around for a long time. They're essentially just a way to segment your network out into smaller, more manageable zones. But one of the exciting things that's more recent is the innovation behind insertion meters, which you can see a picture there of an insertion meter being installed. The nice thing about these is you don't necessarily have to cut into the pipe. You can hot tap it. And so installation is a lot easier. And you can actually start using this as an operational tool. And of course, this is flow data, so it really makes sense to have this over the AMI network as well. And so looking at kind of the data we would get from a district metered area and an insertion meter, what I'm showing here in this graph on the top is the inflow into a DMA. And so that's the horizontal axis is time. And then on the below is the consumption. So that's the aggregate consumption. That is what I was talking about before with grouping. So we can group all those meters up within that zone, sum them together, and that's essentially our consumption. It's shown there as negative because whenever I think of a mass balance, I like to make my control boundary and make sure my signs are correct, especially when I'm dealing with multiple inflows and multiple outflows changes in storage and all that. And so by taking the difference between the inflow and outflow, accounting for changes in storage, we can start looking at water loss on a much more granular level, both spatially if we've got DMAs, but then temporally as well. So this is actually an hourly water balance where we're looking at essentially the water loss in the zone. And there's kind of two interesting things that happened during this date range. One is that there was a hydrant opened illegally. And so now we can actually quantify exactly how much water was lost during that event. There's also a kind of a background leak that was detected and repaired within this network. And so you can see that baseline shift in the data. And I find DMAs are really helpful because they can help prioritize where the biggest issues are. You may want to prioritize this DMA that maybe has 20 or 30% water loss over the DMA that has 5 to 10. But then we can use additional technologies such as acoustics to really zone in on the location. And so this is an example of an acoustic. So this is an accelerometer, so it's external to the pipeline, utilizing that same AMI network to get that data back. And the reason why this is important and really kind of narrowing in on the problem of where the leak is that allocation of staff, as Tom mentioned, is the workforce is retiring. I know one utility we work with, their best leak detection technician is also their best foreman. And he does not have time to go around doing leak detection efforts every day. He probably can really put in just about 1 day per month of actual leak detection time. So his work needs to be focused. And then Tom mentioned water quality contamination or water contamination. And so this is an example of one utility that has multiple water sources. And they realized they wanted to start monitoring at these sources for quality. And you can kind of think of this as pre-treatment. If you've got multiple sources and you can decide which source to draw from, in this case, the utility, both sources feed to the same plant. If you saw a water quality concern at one source, you could switch the other. And so that can be pretty beneficial. So I spent the last few slides talking about how we can leverage AMI to collect more data to solve more problems. And I wanted to come back to why you might choose to utilize your AMI network to do some of these things. And the real reason for that is what I like to call level of service. There's a trade-off between the type of sensing you're doing, the data rates, data transmission rates, and in most cases, battery life. A lot of these things are becoming more and more feasible to do out in the distribution system because of the battery technology that has advanced to facilitate smart meters and AMI reading. On top of that, AMI systems, by definition, cover those end users at the meters. And so by default, they almost always cover most of the distribution system as well. And so you've already got this kind of blanket coverage of the distribution system and a network that was really designed for battery-powered devices with extremely long battery lives. And so the way I like to kind of think about this is there's almost a Pareto front shown here on the right of, in some cases, you might want to have a device that has more data, and that's fine. You're just going to lose some of the power requirements. And so although I love our network, I'll be the first to say it's not for every single application. And so there is still a place for your SCADA system. This does not replace that. There's a place for other technologies. You just have to consider what tool, best tool for the job. And that brings me here. When we're measuring things, you have to remember, what do I need? Do I need the ruler, the tape measure, or the calipers. When I'm cutting things, do I need an axe, a saw, or a scalpel? And what am I transporting? Am I transporting giant boulders or a bunch of water that needs to get to somewhere really fast, or human organs? So when I'm talking about why you might consider AMI devices to monitor your distribution system, it's really about picking the right tool for the job. I'm going to shift gears a little bit because Tom also talked about another challenge about infrastructure resiliency and emergency preparedness. And I think this is really good timing because of the AWEA requirements that, depending on your utility size, is either already submitted or are finishing up some of that work. And I won't go into this totally because we did just give a webinar on this a few weeks ago that really dives into what the EPA calls surveillance and response systems. And this is a framework that can actually help address some of the things that were covered in that AWEA work. But the things I did want to highlight here is that AMI and the monitoring throughout the distribution system can really help with the surveillance side of the surveillance and response system. So it can help provide online water quality measurement. It can provide enhanced security, so like door switches, things like that. And then the metering and tampering and backflow alarms, which actually just as of a few days ago, there was some more guidance released on that from the EPA. But the real key here is that AMI can help in some of these aspects, and you need to have a plan and a system to deal with this information. So in summary, AMI generates a lot of meter data, but it has the capabilities to provide operational data as well throughout that distribution system. And so with the right tools, you can turn this deluge of information to solve problems and save costs, increase revenue, conserve water, and most importantly, protect public health. And so throughout this, I've really been focusing on specific problems, but as you all know, everything is connected. And so I like to focus on, okay, well, if everything's connected, how do we get to where we want to go? And I always like to think about what Stephen Covey said in this very famous book. Chapter 2's title is Begin with the End in Mind. And in fact, we've seen some of our clients really thinking about this in a very, very structured way recently, and thinking about, well, we're adopting this new technology. How do we accomplish all of our goals? So there's a few things that we've come up with to think about as you start with the end in mind. The first is the data. What type of data you need? Where do you need it? How often do you need it? Those sorts of questions. What kind of integration is going to be required? So if you are piecemealing together multiple different kind of data sources, sensing technologies, how are you going to get that data together? Or how are you going to utilize that data? Do the data need to come together? And then, of course, with any sort of technology adoption, which policies and business practices need to be adapted or modified to support these overall goals? Because in the end, technology is just a tool, but we shouldn't let it be our master. And then think about services too. Maybe there's a piece of technology or something that you want to include in your overall goal, but maybe due to workforce attrition or the frequency that you use it, you maybe don't want to have that in-house. Maybe you want to go out to a consultant or a third-party vendor to help with that. And this can help manage risks and assets as well. And probably most importantly, at least in my view, coming from this as a perspective as a civil engineer, the entire water cycle is connected. And so even if you are, depending on your utility, depending on kind of how you're structured, you may or may not have the water and the wastewater, or the stormwater and the wastewater as part of your purview. Maybe they're a different department, maybe they're a totally different agency altogether. But all water's connected, and your AMI system often covers more than just your distribution system. It often covers more than just the water you're responsible for. So I would encourage you to, and I've seen some other utilities reach cross-organizational boundaries to help the other agencies or other groups who manage some of those other water resources say, hey, we've got this technology, maybe it could help you as well. So almost done here, and just wanted to finish off with a quote from the great Canadian philosophers, Rush. If you choose not to decide, you still have made a choice. And I bring this up because on the left here is kind of maybe not a status quo, but if you do nothing, costs tend to rise, maintenance budgets get cut. This is just kind of status quo, unfortunately, for a lot of utilities. And repair costs rise, public perception lowers. When public perception lowers, it becomes a lot more difficult to get those rate increases that you need. And so you're just getting this downward spiral, a negative feedback loop. But it doesn't necessarily have to be that way. By utilizing data and turning information and utilizing the tools at your disposal, you can improve operations and improve efficiency, and then take those efficiency gains and focus those on other areas. So you can leverage those efficiency gains to improve maintenance and lower costs. So think about, like, if you fix a leak, if you fix it before it becomes a burst, that costs a whole lot less than waiting for a burst and having to repair the entire street. And then all of that increases the investment in the tools and the staff. Staff become happier, you have less attrition, revenue increases, and then we're on this virtuous positive feedback. So finally, this is my last slide. I always like to end with some action items. I've been a huge proponent recently of these roadmaps, focusing on functional goals, and then reviewing your infrastructure, your comms, your data, the software, what you need. What do you need from your tools to help you accomplish those goals? For all these things, ROI is important, but that's not always very easy to do. Sometimes you have to take more from a functional benefit perspective. And then consider alternative finance models. There's vendors are getting a lot more creative these days about how they are offering solutions, and so there's more than one way to get what you need. And of course, like I stressed before, it's all about the right tool for the right job. With that, I think that'll wrap up this presentation, and Tom and I are happy to answer questions.
Great. Yeah, thank you, Zach and Tom, for the informative presentation. As Zach mentioned, we're switching over to the Q&A portion of the presentation. As a reminder, you can enter questions in the panel in the left-hand portion of your screen. First question we have here: what do you feel is the most important AMI data to focus on beyond consumption, i.e. pressure, alarm data, etc.?
Excellent question, and I can jump in here, and then Zach, we can contribute if there's something that I think I missed. But the water utilities that I work with on the distribution side, pressure seems to be the one that's most important to them for the many ones that I talk to, and that has to do with it's very important for them. Pressure tells a lot about their system. You know, where they have problems, do they have the right amount of feed going into a particular district metering section? Is there potential leaks? Is there a problem on the infrastructure side? And are they servicing their customers well? So pressure seems to be a very important one, and one that we see a lot of AMI customers now, particularly being able to monitor pressure, either from a metrology standpoint or other products that interface the pressure sensors, and pulling that into software that's able to decipher where they have low pressure and where they have water flowing into a certain area. So pressure seems to be very important. Alarms are another one, a secondary one that they're looking at, particularly on the customer side, like leaks. Many customers, when you have hourly data coming in, they're able to monitor the consumer's consumption, and they're able to contact that customer to let them know that there's a potential leak on their side. So that saves everybody from a conservation side to a customer that is running water when they don't even know they have a leak. So those are two that I can think of off the top of my head, other than the meter reading data.
Yeah, I'll add to that a little bit. Definitely pressure I see from like the distribution side of things is the highest priority, and a lot of that has to do with the ease of install. Pressure sensors are pretty easy to get a lot of places, especially when they're integrated in meters. But then the next kind of step I see a lot of utilities thinking about is flow. So creating DMAs or turning their pressure zones into consumption zones with meters as well. And those really, both of those speak to hydraulics. And then the next step I see a lot of utilities thinking about is quality. So those are the kind of the three prongs, the first two being hydraulics and the last one being quality.
All right. Now, can you share how AMI data could have helped in a situation last month in Texas where whole communities were without water?
Sure, another excellent question. And I know where the technology would have played a key role in some of these customers. And you think about the situation in Texas where they're just not used to that kind of cold weather. And when it hit them on a bunch of different levels. So they were scrambling for finding leaks. So when things froze up, they were out of many areas out of power. And then the cold snap affected not only customer pipes, but infrastructure pipes. So many of the customers that were out of power were out of heat, so therefore they left their homes. And then when temperatures started rising and they were still not in their homes, they had water leaks. And so if the utility would have had, for example, an Ally meter, which has a shutoff valve in it, they would have been able to monitor the consumption at the residential home and notice there was a leak. And if they couldn't get in touch with the customer because they weren't home, they would have been able to remotely shut the water off, therefore minimizing the damage and saving that customer from any further damage and doing it remotely without having to send a crew. So that's just one of the ways in which the AMI data would help. Pressure was another one. They were scrambling to find where they were having leaks with cracked pipes in the street. Sometimes it's not always visible and you don't know until the street caves in. So they were, in some areas they had good data for SCADA, but if they would have had real-time pressure sensors in other areas where they possibly couldn't have implemented, they didn't have any power, they might have been able to identify those leaks a bit sooner.
Great. Do you have anything to add to that one, Zach?
No, I think Tom got it. Thank you.
All right. During the pandemic, do you have any examples of how a utility did use or could have used data collected to help their community?
I think what comes to mind, that's another excellent question. Thank you for asking. I think what comes to mind with the pandemic in AMI is the fact that AMI does not require manual intervention in the field. So those that have had AMI deployed in their utilities, they were able to operate from a meter reading collection with minimal interruption, because many of their workers that either stayed home or got sick, so they were running on scarce resources to begin with. AMI was very crucial in their operational efficiency and allowing them to operate without having to deploy any kind of manual intervention. So it was very beneficial at that point to let them operate remotely.
Yeah, and actually, I've got a little different take on that too. That's definitely one perspective. I sit on a couple of the AWWA water quality committees, and one thing that's been a big topic of conversation since COVID hit is actually Legionella. So the usage and consumption at a lot of commercial buildings or businesses has changed quite drastically. And in some cases, schools have been shut down for months, churches, no one's been in them. And so there's been this real fear that this water has just been stagnant within these buildings for months at a time. And as we know, that's a really bad situation, or creates an opportunity for Legionella to grow. And so one of the things that I haven't necessarily heard about, but I'm pretty sure there's at least a utility or two out there doing it, is looking at some of their customers, saying, now that people are going back into these buildings, seeing which customers maybe were not consuming very much or none at all for extended periods of time, and sending them a note saying, hey, you may want to flush your pipes before really using them. You're at higher risk to Legionella. So I don't know if that's actually been happening, but it's definitely something that the technology is capable of, and I think it would show some really good customer service.
Great. And we have time for one more question here before we wrap things up for today. Do you think the water AMI software available today is mature, or is it still in the infant stage? And if it's still in the infant stage, where do you see additional maturity is needed?
That's a very good question, and I think software in general is always very fluid. We just think about all the new applications that are available. What the phone, the iPhone and Android has done for apps, and every day there's something new coming out. Somebody's always finding new ways to take data or find ways to do things more efficiently. I think in general we've been, AMR started in the 80s where people took monthly reads and did stuff with the data, and then they started adding alarms, and that was all progressing. And we've been in AMI since the 90s, and we're progressing and continually adding different points of data, and along with that is different applications. I know just from a census standpoint that we've got pressure profile app, a service management app, we've got acoustic monitoring apps, and we're constantly developing apps and adding on to our core base. And as I mentioned it earlier, I talked about integrating all of your processes across your enterprise, and I think the industry is going that way to where we can probably have more of a standard data that we can bring everything into one location that the operator of the utility is able to access, instead of jumping into multiple different systems to look at different things. And I believe the industry in the end is going to end up as that as the platform, but I don't know if we're quite there yet. But we're getting there, and it can be done, just a little bit clumsy today.
Great. We have many great questions today that we did not get to address during the live Q&A. These will be addressed offline via email. This concludes today's session of the Water Finance and Management webinar series. Thank you to all of our attendees for joining us today. We'd also like to thank Tom and Zach for their participation and Census for sponsoring today's session. If there is something you missed or would like to refer back to, today's webinar will be archived at waterfm.com/webinars. Any views or opinions presented in today's webinar are solely those of the presenters and do not necessarily represent those of Benjamin Media, Inc., nor does Benjamin Media, Inc. endorse any products or methods presented. Thank you again, and be sure to stay safe, stay healthy, and stay positive. We look forward to seeing you online at a future webinar.